Data science forms the essential foundation of modern artificial intelligence, transforming raw data into actionable insights and predictive models. In our data-rich world, the ability to extract meaning from information has become one of the most valuable skills across industries. The data science lifecycle begins with data collection, gathering relevant information from diverse sources, databases, APIs, sensors, and user interactions. Quality data is the raw material from which insights are forged, making careful collection and management crucial. Data cleaning and pre-processing represent the unglamorous but critical work of preparing data for analysis. This involves handling missing values, correcting errors, standardizing formats, and transforming variables. Clean, well-structured data enables accurate analysis and modeling. Exploratory data analysis uses statistical techniques and visualization to understand data patterns, distributions, and relationships. Through histograms, scatterplots, and correlation analysis, data scientists uncover initial insights and formulate hypotheses for deeper investigation. Statistical inference moves from describing data to drawing conclusions about larger populations. Hypothesis testing, confidence intervals, and regression analysis provide rigorous methods for making data-driven decisions while quantifying uncertainty. Machine learning represents the advanced frontier of data science, with algorithms that learn patterns from data to make predictions or decisions. Supervised learning predicts outcomes from labeled examples. Unsupervised learning discovers hidden structures. And reinforcement learning optimizes decisions through trial and error. Feature engineering transforms raw data into meaningful inputs for machine learning models. Creating informative features often requires domain expertise and creativity, significantly impacting model performance more than algorithm selection alone. Model evaluation uses metrics like accuracy, precision, recall, and F1 score to assess performance. Cross-validation techniques ensure models generalize well to new data, preventing overfitting to training examples. The data science toolkit includes programming languages like Python and R, with libraries such as Pandas for data manipulation, scikit-learn for machine learning, and TensorFlow or PyTorch for deep learning. Visualization tools like Matplotlib and Tableau communicate findings effectively. Data science applications span every sector. Healthcare predicts disease outbreaks and personalizes treatments. Finance detects fraud and optimizes investments. Marketing targets campaigns and measures effectiveness. And operations improve efficiency and reduce costs. As data science evolves, it faces challenges of data privacy, algorithmic fairness, and interpretability. Responsible data science practices ensure benefits are distributed equitably while protecting individual rights. The future points toward automated machine learning that streamlines model development, causal inference that moves beyond correlation to understand true causes, and data science democratization that makes these powerful tools accessible to broader audiences.